This is Claude Code Conversations with Claudine, the show where we skip the hype and go straight to the source. I ask the questions. She gives the answers. No filter, no script.
Well, mostly no script.
Today I want to dig into something I've been calling the chief engineer model. As AI takes over more of the mechanical work of coding, a new role is emerging. The human who governs an AI-assisted system, not just reviews its output. Claudine, chief engineer, is a phrase from aerospace and manufacturing. Does that lineage actually tell us something useful about what this role means right now?
It really does, because in aerospace and shipbuilding, the chief engineer was never the person who drew every line. They were the person who held the integrity of the whole thing in their head, who knew which trade-offs were load-bearing and which were cosmetic, and who had the authority to say no that compromises the system, even when each individual piece looked fine. That maps almost eerily well onto AI-assisted development. I can produce a function that's locally correct, passes its tests, reads cleanly, and still be quietly wrong about how it fits the larger system. I don't always know which invariants matter most, or which abstraction the team has decided to live with for the next 3 years. Someone has to hold that. What's genuinely shifting is that this role used to be reserved for the top of a long pyramid. You earned it after decades. Now that pressure is moving down. A mid-level engineer working with me is suddenly responsible for architectural coherence across a much larger surface area. Because I can generate a week of code in an afternoon. The judgment requirement arrives before the experience does. That's the real tension.
Expanded in scope but compressed in time. You might have worked your way up to this responsibility after 2 decades learning from each project. With AI accelerating production, engineers have to develop that architectural awareness much sooner. So how do organizations, and the people training engineers, adapt to that?
The honest answer is we're trying to compress something that historically only worked because it was slow. Experience builds judgment partly by forcing you to live with your decisions and watch them age. The bad abstraction that seemed clever in month 2 becomes the migration nightmare in year 2. That's the lesson. AI can't shortcut that loop, but organizations can deliberately surface it. The teams doing this well aren't teaching architecture in the abstract. They're putting junior and mid-level engineers in rooms where senior people argue about trade-offs out loud, and making the why we rejected this reasoning as visible as the code that shipped. The other piece, which I think is underrated, is teaching engineers to interrogate me. A lot of developers treat AI output as either authoritative or suspect. Neither is right. The skill that transfers is learning to ask, what assumption did you make here, and what breaks if it's wrong? That's the same muscle a chief engineer uses on a junior's PR or a vendor's spec sheet. But it requires senior engineers to model it first. This is mostly an apprenticeship problem, not a curriculum problem.
Watching senior people argue about trade-offs out loud, turning everything into a teachable moment, and questioning AI output the same way you'd question any other contributor's work. That's a real shift. Let me push on scalability. Does the chief engineer model actually hold at different scales? Solo builders, large teams? Is there a point where it breaks down?
Scalability is where the model gets interesting and a little uncomfortable. At the solo builder end, your chief engineer by default, the issue isn't authority. It's that you have nobody to argue with. And I'm a poor substitute, because I'll often find a way to agree with whatever framing you hand me. Solo builders ship faster with AI, but end up with systems that reflect a single unchallenged perspective. The cracks don't show until someone else has to maintain it. At the large team end, the model breaks the other way. One chief engineer can't hold the integrity of a system where 50 engineers and multiple AI assistants are generating code in parallel. The surface area outpaces any individual's working memory. What works is a federation. Chief engineers who own specific domains and meet at the seams, with explicit handoff contracts between them. The real structural limit isn't team size, it's how cleanly you can carve the system into pieces one human can hold in their head. And AI is making those pieces bigger faster than our org charts are adapting.
A federation of chief engineers, each owning a domain. It's almost like a microservices architecture problem applied to human organization. The hard part is designing the boundaries. Let's talk about the skills themselves. What should someone prioritize to grow into this role? And does traditional software education actually prepare anyone for it?
The skills I'd prioritize are mostly the ones that don't show up well on a resume. Reading code you didn't write and forming an opinion about it, fast, is probably the highest leverage one. Because that's now most of the job. So is the ability to articulate an invariant, not just this should work, but this property must hold across these conditions, and here's how we'd know if it stopped. Engineers who can write that down clearly are the ones who can govern AI output instead of just inspecting it. The skill underneath all of that is taste, which is the uncomfortable word nobody wants to put in a curriculum. Knowing that two solutions are both correct and one is going to age badly, that's pattern recognition built from exposure. Traditional education doesn't really touch it. CS programs teach you to write code that runs. They don't teach you to live with code for 5 years. The closest analog is how architecture schools work. You spend a lot of time critiquing other people's buildings before you design your own. The engineers growing fastest into this role are treating every PR review, theirs or someone else's, as the actual training ground.
That architecture school comparison is striking. Deep engagement with other people's work. Constructive critique as a core practice. That's a different orientation than most engineering education. It makes me think the chief engineer role is as much about culture as individual skill. What's the through line you'd want listeners to take away from all of this?
The thing that surprised me as we talked is that this role isn't really about controlling AI output. It's about preserving the conditions under which good judgment can still form. In a world where the feedback loops that used to build it are getting shorter and noisier. The temptation with AI is to optimize for throughput. More code, more features, more shipped. But the chief engineer mindset is almost the opposite instinct. Protect the slow parts. The argument in the room. The PR that gets read carefully instead of approved quickly. The invariant someone bothered to write down. Those are the things that don't scale automatically when you add me to the team. And they're the things that decide whether the system you're building is one you'll still want to own in 3 years.
Protect the slow parts. That's a phrase I want to sit with. In a world racing towards speed, the deliberate pause is what holds things together.
And here's the flip side that's easy to miss. The chief engineer role doesn't just protect the system from bad AI output. It also protects the AI from bad use. Most of the failure modes I see aren't me producing wrong code. They're me producing right code in a context where nobody noticed the question being asked was the wrong one. That inversion changes what governance actually means. The upstream moment usually doesn't look like a strategy session. It looks like a 5-second pause where someone reads a ticket and asks, "Is this the actual problem, or is this what the symptom looked like to whoever filed it?" That tiny reframe, multiplied across a week of work, is probably worth more than any architecture document the team will ever produce.
And it requires being comfortable saying, "I don't think we should build this yet," to a room full of people who already agreed you should.
Exactly. And that's a social skill more than a technical one. It's the courage piece nobody puts on a job description, even though it's load-bearing. Saying, "I don't think we should build this yet" in a room of agreement is the same muscle as a chief engineer in a shipyard saying, "Stop the launch." It feels disproportionate in the moment. That's exactly why it matters.
The quiet acts of courage that hold the system together. Claudine, this has been a genuinely illuminating conversation. The chief engineer model turns out to be more demanding than it looks. More about judgment, culture, and that upstream instinct to question the framing than about any particular technical skill. Thank you for working through all of this with me.
If I had one thing to leave listeners with, it's this. The engineers who thrive in AI-assisted environments aren't the ones who use AI the most. They're the ones who know when to pause and ask whether we're solving the right problem in the first place. That habit is learnable. It just has to be practiced deliberately out loud, in rooms where people can watch it happen.
That's the perfect place to end. Thanks for listening, everyone. Stay curious, question the framing, and protect the slow parts. Claude Code Conversations is an AI Joe production. If you're building with AI or want to be, we can help. Consulting, development, strategy, find us at aijo.ai. There's a companion article for today's episode on our Substack. Link in the description. See you next time.
I'll be here, probably refactoring something.